Hey everyone, today we will see the matrix. Now, what is a matrix? A matrix is a collection of data elements arranged in a two-dimensional rectangular layout. So here you can see one example. This is a matrix where we have the values in a row as well as in a column. Okay, and to define this type of matrix, okay, the command is something like this. You have to pass on the function matrix, then the values 1 till 6. So you can see here from 1 till 6 the value is passed, and then the number of rows and the number of columns you want your matrix to be. Now one key important thing that you should remember is that when the matrix is created, okay, it always fills the rows first, okay, and then it creates the columns. So here you can see it's created the 1 2, the first two rows, okay, and then the 3 4 5 6. Okay, so that's important thing that you should remember. We just create one matrix. Okay, yeah. So let me create one matrix. So I create a matrix M. Okay, and now I pass the values like how we pass a vector array to create a value. So I create, let's say, um a matrix with random values. So how many six values are there? Now how many rows I want? So I want two rows. Okay, so I create two rows and then two columns. Okay, so three columns. Okay, now here you can see it shows your M as a type numeric. Okay, and then it shows there are two rows and three columns. To see this, let's see. Okay, now it has created a vector for us. Okay, now what will happen if you have you don't have a complete list of six values? Okay, if it is only five values, okay, how you want to create the matrix? Now if you try to create a matrix with just five values, okay, so I will repeat this above example, but now I don't pass on this value as 12. Okay, so now the total items are 1 2 3 4 5. Okay, and I'm asking to create a matrix of dimensions, two rows and column 3. Now R will throw the error because he don't understand, like, how he can create a matrix out of it, because the number of items, okay, so data length 5 is not some multiple of rows and columns. So 3 by 2 is 6, so we should pass the 6 values. Now you maybe you remember that if you want to pass some blank values, okay, we have to use the NA. So now if I try to create it, okay, my matrix is get created, and for this missing value, the value NA is added. Now many times it is possible that you want to convert the existing vector into a matrix for maybe calculation purpose or many different purpose. Now there are two ways by which you wanted to convert. Either you want to convert a existing vector into matrix by converting into a rows or columns, or there might be another instance where you want to combine two different vectors together and create a matrix. Now let's see one by one. The first one is how we convert a single vector into a matrix. So it's pretty simple. You have to use the dimension function that actually defines a particular matrix, how many rows are there and how many columns are there. So that is how dimension function acts. Now you have to pass on the values like how we use it to define a names. Okay, so if you just call the function names, then it will return the names of the value particular vector item names, and if you just pass on the different array to it, it will create uh, names for that particular components. Now let's see this in our example. So here I go and I create a single vector. Let me create a vector. Uh, so let's create a vector of value 1 till 10. Okay. Now let's see what it holds. It has values from 1 to 10, and let's try to see the dimensions, what dimension it has. So typically a vector don't have a dimensions because we don't have a rows or columns. So that's it. See here it's saying a null because there is no rows or column defined for this vector. Now let's convert this vector, okay, into a matrix. So to do that, okay, I have to use the same above function, but now I will pass on the values. Okay, so I want 2 rows and 5 columns. Okay, so 2 by 5 is 10. So there are 10 items in our vector. So let's see. And now let's see what happened with our earlier vector when it converted into a matrix. So see here it's now converted into a matrix, and now let's see what is the dimensions it is holding. So 2 by 5. Okay, that's what we passed. It's 2 rows. Okay, 1 2 and then 5 columns. So that is how you can convert a single vector into your uh, into matrix. Now there is another requirement. Let's say you want to convert two different vectors. So I create the first vector x as 1 2 3, and then another vector y as let's say from 4 5 6. Okay, so now let's try to bind it. So to create uh, row wise, okay, so we want these two vectors to be bind as in a row, so we can do it with row bind. So let me create another this matrix. So I use the function rbind. Okay, and then I pass the x and y. Okay, and let's see what is the value in rb. Now you can see here it's 1 2 3 4 5 6. Now what do you think if we use the function cbind, and now see rc. So here you can see how the values are arranged. Okay, so in the first case, when I use the function rbind, okay, this two vector, the vector 1 is actually put it into the row. Okay, and then the next vector is added into next row. Whereas if I use the function cbind, okay, the first vector is now put it into in a column. Okay, you see here, and then the next one y1 is added here. And now one thing that you should see here, that that individual columns has been given a name in case of cbind. Okay, the vector names itself. And the same way when we use the rbind function, the row has been given the respective vector name. Jumping to the next topic, accessing the elements uh, from the matrix. It is same how we used to do it in case of vectors, but now vector was a single dimension. Okay, it doesn't has any rows or columns, so we were just passing one value. Now here in this case we have two values. So one you have to pass a row, and then the second one as a column. And then another thing that I wanted to discuss is like how you can select the rows and column. It is pretty simple. You just don't have to pass any values. So let's say when I want to select only rows, the second row completely, I just pass value 2, and then I keep this column value as empty. So it means I want all the values that are there in the row second. So let's see in our example. I just clear out the screen, and then let's see our vector v. Uh, yeah, so this is our currently matrix v, and then I wanted to access the value at the second row, second column. Okay, that's the 4. To access it, you have to pass the second row, second column, and the value 4 is written. Okay, now to access completely a second row, okay, I will use the same thing. Okay, but then I'm not passing any value. Now it will return me the second row as it is. Now to get the, let's say, the third column. Okay, so I want the third column 5 6 values. So to do that, now I don't pass the any value for a row, but I will just pass the value for a column. So it will return me the value 5 and 6. Okay, so this is pretty important to remember how this value you can access. We will be using this going forward when we work with a different example. Now assigning the names. Okay, so this how we have done it to a vector. You assigned different names. So same way it is possible to give a matrix a name, but here you have to use the function as a list. Okay, we will talk about list in the next session, but now just try to understand here that using this list function, okay, you can pass on the names. So you remember that I have a dimension m, okay, sorry, a matrix m, which has a value 1 till 10, and then to give it a name, okay, you have to use this function. So it is a dim names. Okay, and then you pass the your matrix name, and then you have to pass on the list with the first parameters as a row name, and then the second parameter as a column name, and then it will create a uh, it will name that particular items with particular names, and then you can access it just like in a vector by particular names. We will see this in detail much in the next few sessions, but now the last part is about matrix computations. It's similar to how we used to do it in our uh, in case of what do you say vectors. Okay, if you just multiply by any value to a matrix, for all the components that value is multiplied or added, so as per the basic operator you use, the values are calculated. Similarly, there might be a case when you wanted to do a calculation on a two different matrix, so you can do it using this. So let's try out our example. I will clear my screen first. Okay, and then I'm just creating two matrix. Now I clear this environment also, so we have a clean environment, and now we have a two matrix, matrix 1, matrix 2, and let's see what how they are so here is our matrix 1, and then let's see what is matrix 2. So now you see here 1 5 3 7 2 4 6 8. Now let's do a simple maths. Okay, so I wanted to add 3, okay, into matrix 1. So now I add matrix plus 3, and then it will add a 3 value to all this components. Sorry, I forgot to give as a number. And here you can see 1 plus 3, okay, it's 4, 3 plus 3 6, 5 plus 3 8, and then 7 plus 3 10. Now how let's do a addition of two different matrix all together. So now here I do matrix 1 plus matrix 2. And now here you can see 1 plus 2, that is 3, then 3 plus 4, 7, 5 plus 6, 11, and then 7 plus 8, 15. So similarly you can do the multiplication, subtraction, or whatever things you want to do. Thanks everyone.